In this video, we're going to begin with a discussion of some properties of matter. So we can break apart or kind of separate properties into two categories. Physical properties, which can be observed without changing matter. So we'll say without changing the matter that we're observing. Some examples of this could be observing boiling point or density. So these are volume, color, mass, freezing point, right? So we can add a couple more to this list. These are all physical properties and can be observed without changing the substance, changing the matter. Now, chemical properties, we can observe these only when the substance is changed. So, for example, the flammability of something. Double M. So when you light something on fire, you're going to change it, but you know if it's flammable. If something is reactive with acid, if you dissolve something in acid, you're going to change it, but you know that it will react. And corrosiveness, that's another type of chemical property, so corrosiveness. So something will corrode, it's going to change, but we can observe it then. So know the difference between physical and chemical properties. And then we have another way of defining properties as either intensive. So this will be independent of the amount of matter. So it doesn't matter how much matter you have. You can have a gram, a kilogram, whatever. These examples include density again. So density is an intensive property. If I have 1 gram of water or a kilogram of water, it will still be 1 gram per milliliter dense. And then we also have things like boiling point. Again, that would be an intensive property. Doesn't matter how much you have, water will still boil at 100 degrees Celsius. Let's see, we have extensive properties. So this depends on the amount of matter. So we'll just say on the amount. And an example of this could be mass, right? How much something weighs on a balance, its mass is dependent on how much matter is there. Volume, also how much space something takes up. And then we have some other ways of defining matter through what are referred to as physical changes or chemical changes. So physical change, this does not affect composition. So we'll say does not affect composition of your matter. And an example or two of this could be a changing state. So change of state. So phase is another way of saying that. So going from solid to liquid to gas, that would be a physical change. So things like evaporation, a change in temperature. So temperature change, that doesn't affect the temperature change that doesn't affect your composition through phase change, volume change. So if you half the volume of something, etc. So then we have some chemical changes down here, and these will result in a new substance. So we can say result in a new substance. So some examples of this could be a combustion. So you blow something up under oxygen, you combust it. For example, methane gas, you're going to get carbon dioxide and water. Any hydrocarbon, we get the same two products. We'll see that later on. Another example could be oxidation. So you're going to change the composition of your matter if it combusts, if it oxidizes, if it decomposes. So we'll also list decomposition. So these are examples of different properties and ways that we can differentiate and observe matter and sort matter into different categories. And we're reminded here that during a chemical reaction, the reactive substances are going to be converted or changed into new substances. So let's think about this example here. We're going to give it some thought here um, and decide which of these changes are physical and which are chemical, and then give a brief explanation. So plants make sugar from carbon dioxide and water. So we ask ourselves, do we have the same stuff at the start and the end? So we start with CO2 and water, and then we end up with sugar. So no, we have different substances, so this would have to be a chemical change. Water vapor in the air forms frost, so we have water to start in gas phase, and then we have water over here in solid phase. So this is just a physical change. We have a change of state, but we don't change composition. Last, we have a gold nugget, and the goldsmith takes that gold nugget and pulls it into a wire. So we have uh, gold to start. We still have gold at the end. So that is another example of a physical change. We don't actually change the composition of our matter. We just change its form or its shape there. So we can talk about in this last section here how we can separate mixtures. Separation of a mixture into its component can take advantage of differences in properties. So different types of matter have different properties, and we can use that to separate these mixtures. So filtration, if we have a solid that is in a liquid, for example, we could filter out the solid from the liquid. We could also distill. So say we have two liquids and they differ in the physical property of boiling point. We could separate them, this homogeneous mixture. So we can't tell the difference between, say, methanol and ethanol in something like moonshine. So it's distilled to separate them based on their boiling point. And then this you might talk about in organic chemistry, where we can use something called chromatography to separate compounds based on their solubility in a certain solvent. So again, we can just use some physical properties like these mentioned to separate mixtures. And we'll continue with the next topic in the next video.